It was just default route injection in the EIGRP. How to inject a default route in the EIGRP. It's
Okay.
very small topic. I just created the static route and just I redistributed in the EIGRP.
And
Now,
normally this default originate command
this is not for
that
the EIGRP. This is for the
is
OSPF.
OSPF. Yes.
Yes, we'll see later on.
Thank you.
Okay, welcome, Jishan. So now we have to jump on the OSPF. So first, before we go and do lab and all, right? We have to understand the OSPF fundamentals. Means we have to understand what is the OSPF, right? And what is the difference between the OSPF and the EIGRP? And what was the problem with the other routing protocols, which OSPF is going to solve that? How OSPF algorithm going to work? This fundamental we have to understand. Because OSPF is one of the protocol which is going to be widely used across the industry. Means EIGRP is good, right? But it is limited to the Cisco, even it's an open standard right now. But still it is not going to be used for any another vendor, even the FortiGate firewalls, Juniper routers, Huawei router, Nokia routers, Versa router. They not support the EIGRP. Even the Cisco itself, their SD-WAN solutions not support the EIGRP, even Viptela boxes. Even Cisco routers support the EIGRP, but non-Cisco routers, they never support the EIGRP because it was the earlier proprietary of Cisco. So no other vendors are going to promote that particular protocol. So even OSPF is quite popular, but it's very complex. If you just compare with the EIGRP, EIGRP is okay. They are very fast. They have the always backup path. But OSPF also act as a like whole topology table in their brain. And by sitting in the one location, he know what is my primary, what is my secondary, what is my tertiary path. Think about a GPS map. GPS map always having the multiple path availability. And for any regions, any point of time, any path is going to be fixed, right? Break, then it is going to be automatically fix the path by changing the path. Think about this way. Let me open one of the Google map again. So if I just go in the airport and I will just see the directions. Okay. So you will see various path is there. So by sitting in these locations, I have the complete visibility how I can reach from this location to this, because this path is one, this path second. So it will automatically calculate which path is better and which path is best and which path is slower. This OSPF is known as open shortest path first. Why open shortest path first? Because it's just use the algorithm that is going to select the best path out of all available path, and that's again fall under the category that is the IGP. Okay, because IGP have the EIGRP and also they have the RIP and static routing, ISS. This all are the your OSPF. OSPF come in two flavors, right? Normal OSPF, OSPF V2, that is for the IPv4, that what we are going to learn. But we have the another OSPF, that is the OSPF v3, that is for the IPv6, that also we are going to do that later on. So how this going to be operate? This OSPF is never going to use the AS number, means no AS number concept is there. This is just going to use the concept like areas instead of the AS number. They are going to use the algorithm that is known as the SPF, shortest path first, which is known as the Dijkstra algorithm, right? Dijkstra algorithm that's open the shortest path first. This is known as the shortest path first algorithm. And by using this algorithm, they calculate the best path, and the cost means when the multiple path is going to be there, In the EIGRP, the cost, the metric was their composite metric. But here, the metric is not composite metric. They use the cost. Cost is the metric. That is going to depend on the your links. So I will show you how this cost is going to be even calculated later on. But the key concept, whenever you're just going to be calculate the OSPF cost, your link speed is going to play a very vital role, even that in the OSPF. And why OSPF? Because they have the complete LSDB. LSDB is known as the link state database. By sitting in the one locations, you're going to stay in the any one locations. That locations router is going to be maintain entire LSDB link state database, and they're going to use the algorithm that is the shortest path algorithm, that is discussed algorithm. They're going to be choose how and where I need to send the packet, and also they use the unique address. There's two address they're going to use. That is multicast address. This is going to be 204.0.0.5 and one is going to be 204.6. Means every router, not every router. Some router is going to use this one. Okay, some router is going to use this one. I'll explain what is this router and what is that particular router. But there is a concept of DR and BDR. Election also going to happen. So I'll explain one by one, but they use the multicast address. And this multicast address even going to be select your all, means any DR is going to be used. Right now you don't know what is DR and don't know VDR, but DR is going to use always this multicast address and BDR is going to use that particular multicast address. The topology, whenever you're going to use OSPF, the topology is going to be always loop-free routings, very scalable routing, and the convergence is going to be very fast. Why fast? Because they have the central brain where we have the entire routing informations. So if I go in the topology, let me go here and I will show you at any point of time. I'm here and I just go to this any destinations. If this path goes down, it will automatically switch this path. If this link goes down, automatically recalculate again the path. So it's very flexible. It's going to support your IPv4, IPv6 both. It's not Cisco proprietary, so it is going to use it is going to use by any vendor. It's Juniper, Versa, Cisco, Huawei, Nokia, whatever the router you have, that every router is going to be use this particular OSPF protocols. Unlike the EIGRP. If I compare with the OSPF with the RIP, so RIP is, we know that that is a distance vector, and they not support the hope more than 16. Okay, maximum 15 hope is going to be there, 16 hope it is going to be out of reachable. But in this OSPF, there is no such kind of the hope restrictions. They are going to use the cost. That is the metric. But in the REAP, the metric is going to be your hope counts. Convergence, OSPF is fast, REAP was slow, right? And what else, right? The REAP was designed for the small network, but here it's going to design for the your means very bigger network, OSPF, right? And in RIP, we don't have the entire topology informations in one go, but in OSPF, we have the everything. But if we compare the OSPF in the EIGRP, so what is going to happen? OSPF into EIGRP, so you're going to be find a lot of differences. Like if you go in the OSPF versus EIGRP, so first EIGRP is going to be your hybrid protocol. That's using the both property distance vector and the LSDB like that. But OSPF is pure link state. They don't have the distance vector kind of the calculation. Second, the metric. Metric I mentioned in OSPF we have the cost, but EIGRP you have the composite metric. This OSPF is the open standard, and your EIGRP is going to be your basically Cisco provided. Now it's open standard, but no other vendor supporting. It's going to be fast convergence in both of the scenario. In EIGRP, they use the dual algorithm. Here they use the SPF algorithm. The EIGRP is going to use what they can use. They can use the area, not area, sorry. They use the yes, area idea, not area, AS number. And here it is going to use the area in the OSPF. So there are a lot of differences we have. More complex OSPF, VHRP is similar. It's very high CPU utilizations, lower CPU utilizations. It's open, Cisco proprietary, multi-vendor yes, no, multi-vendor not supported. So these are the differences we have between the OSPF and the EIGRP. BGP will discuss later when we'll just discuss about that in more detail, right? All right, so I believe we have the basic fundamental of the OSPF. Now, if I talk about a little bit more about how this SPF algorithm is going to work, because that's the key parameters. Whenever you talk about the OSPF, your SPF algorithm is going to be always shortest path fast algorithm is going to be there. Because why it's very important? It's going to be a scale your entire topology into multiple areas. It might be the single area that is known as the backbone area, but that is not recommended to connect all your AHRP topology in the backbone area. No. So there might be the normal area, there is a backbone area, area 1, area 2, area 3. Whatever the area 0 we have, that is known as the backbone area. So they design topology in such way. This might be the area 0. This is going to be known as the backbone area. But this area, another area is going to be connected area 1. This is known as the non-backbone area. It's known as the normal area. Okay. So inside of area, we can put the multiple routers like R1, R2, and R3. Here is R4. This area is going to connect, this router is connected to area. So every router have their own rules. Some router is going to be your DR, some router is going to be your BDR, right? Some router is going to be DR others, right? Some router is going to be ABR, some router is going to be ASBR. So we have different rules also inside of the areas. So DR is designated router, BDR is a backup designated router, right? DR other means they are not either DR or BDR. ABR area border router. ASBR is area this is ASBR. I just forgot the name. Sorry, let me. So this is known as, I just forgot the name, autonomous system boundary router. Okay. So this is known as the SBR because which is going to use to connect to two different area. So we have the different rules as well. And also if I talk about, they use the LSS, means they are going to use the LSS like LSA1, LSA2, right? LSA3, LSA4, and 5, 6, 7, 8, 9, 10, 11. So they have the multiple LSA, even the OSPF. And also they have the multiple states. So we'll discuss one by one. What is a DR? What is a BDR? How the DR others? But the fundamental, whenever SPF compute the, means the, it's going to be calculate the shortest path. The each area have their local routers and each routers, even local routers, DR, BDR routers, ABR routers, they are going to build their own database. And these database are going to be exchanged between all the routers. So they know how to reach and where to reach from one source to another destinations. Clear? And also this particular LSDB means database, that's going to be make sure entire routing updates they have the up to date. If anything is missing, they will send the again update packets or request packet, link state request, link state update, or link state acknowledgement. There are three packets going to be there: LSR, LSU, and LSAck. Link state requestment, update, and acknowledgement. Anything they require further to just make sure I won't get more informations, they're going to be use that information also. Okay. All right. So let's discuss a little bit more about that OSPF. Till now, any questions, guys? Because I'm just talking about the story, normal story. I'm not going to much technical. General story, I'm talking about the OSPF. Any questions in your mind?
These three link state advertisement is LSR, LSU. who will generate this? All the routers or only switch?
I'll come. I'll explain one by one. Okay, everything.
Okay.
I'm just giving the overview, right? We have to cover these all things in very depth. Okay,
Okay.
so that's a good question. Now, one more thing. If I talk overall, this OSPF AD value, AD value is going to be 1110 OSPF, just one AD value. And this is going to be use the protocol number 89, OSPF protocol number, right? And the metric is going to be cost. And this is going to be calculated based on the your link bandwidth. Let me show you. We'll see how it is going to be calculated. See, if you have the link, right? You have the default, we have some kind of the 100 Mbps, 10 Mbps, right? 384 Mbps. So could be anything. And this is going to be your calculated by the metric. So this is going to be OSPF link metric calculations as well. So I'll explain also the table also, how it is going to calculate the metric. Another thing, let me go here. I will just think about their hello and dead intervals. So by default, when we have the two web network, one is going to be your by default point to point and any broadcast network. So the default timer is going to happen. Default timers 10 seconds and 40 seconds. That's the default timers for the OSPF. For any kind of the broadcast network. Broadcast means if I am the one router, another router, and they are connected to the same network. Let's suppose 10.10.10.0/24. So this is the one broadcast network. So if they are going to just build the OSPF network, they keep sending the hello Mac packet after 10 seconds. And if they are not going to get reply within 40 seconds, they will declare my neighbor is dead. But think about this is non-broadcast network, non-broadcast like frame relay and all, like or point to multi-point network. This timer is going to be 30 seconds and 120 seconds. Even you want to minimize or you want to like maximize the timer, it is absolutely possible. You can do that. Clear? So timer, default timer for the OSPF is going to be 10 seconds and 40 seconds for the network, which is going to be your any kind of the broadcast. But if you go for the non-broadcast, right, it is going to be different value. And for the hello and dead interval OSPF for point to point network, it is going to be same. So point to point also, this is going to be 10 second, hello and 40. So point to point and you have the broadcast network, it is going to be same. But if you have the multi-access network or non-broadcast network, it is going to be different, 30 and 120 seconds. I hope it is clear. So these are the key value you have to remember. What other things you have to remember? You have to remember when I talk about the cost, by default reference bandwidth, whatever the metric you're going to calculate, this metric is going to be cost, and they take by default reference bandwidth is 100. And each interface, whatever the interface you have, interface could be your Ethernet, you're going to be fast Ethernet, it is going to be gigabit Ethernet, or it is going to might be the 10 gig Ethernets, or might be it is going to be serial link, quite slow serial links. They're having a different cost. This link is going to be higher cost, like 64. Ethernet is going to be 10. It is going to be 1. It is going to be 1. It is going to be 1. So if I go here, OSPF matrix calculations, and let me show you the table. I can show you. This is going to be somewhere. You can see here. Here you can see. If you have the serial links, right? They're not given the cost value. Okay. Okay, so this is the reference bandwidth. So how to calculate the cost? So 100 divided by the bandwidth. Let's suppose you calculating the example for the Ethernet. Ethernet having a 10. So the cost is going to be 100 divided by 10. So it is going to be 10. But if it is going to be a serial link, then your whatever the reference bandwidth, by default reference bandwidth is going to be 100 divided by 1.54. So it is going to be, this is your like metric. But if I just talk about this one, 56 kbps. So 100 divided by, if you convert 56 kbps into Mbps, let me do that. 56 kbps into Mbps. So you just copy it, sorry, and 100 divided by this one. See, so this is going to be your metric. Okay, so you know how to calculate the metric. So if I just take the example, fast Ethernet, so 100 divided by 100. So it's going to be 1. So it's 1. But if you take the gig, so it is going to be 1000. So it's going to be 0.1. So it is going to still consider as a 1 as a metric. So any link more than 100 Mbps, always the metric is going to be, or cost is going to be 1. Clear? And the formula is, it's going to be a reference bandwidth. Whatever the reference bandwidth you have, just divide by the metric. And if it is going to become any value as a fractional, just go nearby value and make as a bandwidth. Is it clear? The calculation is clear? How to calculate the metric in the OSPF?
Yes.
If not, just follow this rule. Whatever the table we have, just follow the table. Like this table. This table you just follow. Or by default, you follow this. Any link more than 10 Mbps, the always cost is going to be 1. If any link is slower link, just divide by 100 by total bandwidth. That's a simple calculations. Okay. What else? In OSPF, I mentioned that all routers, whatever the routers we have, okay, in network, I mentioned 2 multicast address. Like we have the router type. One is the DR, one is the DR others, and one is the BDR. Okay, these 3 roles is going to be there, all routers. And also we have 2 multicast address. So I just explained previously, these 224.0.0.5, 224.0.0.6. So which router is going to use this .5 multicast address? In which router is going to use .6 multicast address? This question might be going to ask in the interview. So very first thing, DR and BDR, if they are going to be selected, they just going to use this address. But even DR and out of BDR, only DR is going to use this particular address. If DR going to fail and if going to become this as a DR, then it is going to be use this address. Means if I say technically which router is going to use this .6, only DR, only active DR designated router. I'll explain what is a DR. Will we use 224.0.0.6.
You mean BDR?
No, only DR. Active DR means who is the DR that is going to use. Not
Okay.
clear?
I
Okay,
thought 5 is used by DR.
no, no, no. No. DR is going to listen on the 6, okay? Remaining router is
Okay.
going to use the 5. You confused me. Hold on.
Okay.
Uh, SPF multicast address. So you can see OSPF 2 multicast address, OSPF. See, this is a 6 designate, right? And backup designated router. But this is partially true, okay? Backup designated router is going to use, right? But technically, if you test in the lab, right? That's why I wrote here, right? DR BDR is going to use. The first statement was this because of this statement. If you go on internet and are going to read it, it is written here 224.0.0.6 designated router backup are going to use this particular packet. But active DR, when you took a debug and all, I will try to show you. Only 5 is, 6 is going to use very DR. BDR is generally going to use the 5 address. We'll check it later on. But theoretically, if someone is going to ask, you can just roughly say that DR BDR is going to use by the this multicast address. Rest other routers, non-DR BDR is going to be used by the all OSPF router. Clear?
Yes, sir.
So you have to take a special note, right? So these two multicast address, and whenever you just going to be used, whenever you're just going to be uh, configure it, it is going to be by default initiate the default multicast address. This one means whenever going to configure the OSP very first time, even we not have the DR BDR, they will by default use this multicast address. I will show in the lab also. Let me show something else. Let me open a book as well. Give me 1 second. So I can open a book as well. Okay, here NRC. Because we have to understand fundamentally these all things to make a very good base. So if I go here and go in the OSPF, let me show you. So I discuss this all things. Okay, so I'll discuss area and all, but we discuss the OSPF fundamental. OSPF advertise the link state, right? Advertisement, the LSA that contain the link state and the link metric to neighbor router. Receive the LSA are sorted in the local database called the link state database. What I was explaining earlier. And this LSA is just going to make sure all the configurations which is going to be updated and the path is going to be calculated which path is best to reach to any network. They use the area. How area is going to be there, I'll explain later on. But there is special area, ABR, ASBR, we have discussed. Now, these are the OSPF packets. So you have to be understand, right? And here inter-area router communication, all OSPF router that is going to use this particular multicast address, and by default this multicast address having this MAC address. And all DR, this is what I was talking. See, official book it is written. So it's quite contradictory. Okay, guys, very important. Why I mentioned that there is no BDR written here. You can see in the official books. So somewhere you're going to find DR BDR, but technically, DR is going to use this .6 address, not BDR is going to be used. If you just check in the debug and all, you're going to find. So except DR, every router is going to use this multicast address. Clear. But if you see here in the Google, you find DRBDR, and some other books also are going to find DRBDR is going to use, and even more people in generally going to say that it's DR and BDR is going to use that particular .6 address. But that's quite confusing and always having a debate point. So always proof in the lab and books written here, Cisco Press, DR routers use this address and BDR
So
is here.
I have a question actually. It is written all routers running OSPF should be able to receive. Means
Yes.
who will be sending? Any router is sending, so they will receive on this, or only DR will send with 0.
Basically, what happened in area, everyone is going to send the LSA information to DR. Okay. And DR is
Okay.
going to further send to the other DRs.
So
So,
DR will send with this 05.
yes, yes, yes.
Okay.
Now in OSPF, we have the multiple packets. So they have the hello packets, database packet, link state packets, link state update packet, and link state update packet. So we earlier talking about the LSR, LSU, and the LSA. But in neighborship, whenever you want to build the neighborship, you have to be follow these five packet, detailed communication. If this five packet detailed communication is not going to be happen, it is not going to make the neighborship. And if I just discuss one by one all the packets, right? Then how it is going to happen? So all the packet, let's suppose the hello packet itself is going to be kind of the very detailed informations. In hello packets, it is going to be contain multiple informations when we're going to build the OSPF neighborship. Likewise, it's going to contain the area ID, right? It is going to contain the your network mask. It is going to be contain your area type. So even the authentication parameters. So a lot of things is going to be there. So if you want to just build the neighborship between the two routers, all mandatory parameters must be going to match. If it is not going to match, it is not going to form the OSPF neighborship. That's simple, like logic of the OSPF. So if I just show you, means what are the parameters is going to be part of the hello, then you guys will understand. So let me show you all the, how can I show you? For that I have to debug and all. So, or might be this book also have the hello packet. Yeah. So see here. Hello packet field. So these are the very minimal things, not okay. They have the all field. Okay. So they contain the router ID, right? Very unique. Authentication is optional. It's not mandatory, but mandatory is the area ID. Interface address mask means where you creating the any OSPF neighborship, that network mask should be not mismatch. Exact mask should be there. Priority, if you configure any priority, that is also going to be carry between the both sides. If you're not configuring any priority, by default, it is going to have the one priority. Hello interval and dead interval should be also match. Any designated router and backup designated router information also going to be there, right? Any area, like if you have area type, it must be there. Area type, it's yeah, area ID, area type. Also, it is going to be there. And active neighbor detail. So this is going to be by default part of my OSPF neighborship. Means what does mean? Means whenever you want to build any OSPF relationship. So let's suppose this is my R1. This is going to connect my R2. So whenever you have, let's suppose 10.10.10.0 network slash 24 dot 1 I configure here, dot 2 configure here. The moment you enable OSPF on the link, enable OSPF on the link, it will send the hello packet to its neighbor. And inside the hello packet, it is going to contain all the parameter. Means what is the, like, they have the router, means the, not router, the area ID, authentications, they have the subnet mask. You just have to remember these all value, because interview they are going to ask hello and dead intervals, hello dead intervals. It's going to be carry the priority, DR, BDR, IP details. They are going to be carry the area details, right? And there is no router ID. If you have router ID, process ID is not going to be carried. Some kind of going to ask the process ID. And if the same value is going to match, when this is going to be enabled OSPF here also. Enable OSPF. If this OSPF is going to enable, this is going to also send the same value. If both value is going to match, what sending this side and this side, then only you are going to be in next state for the further talk, right? And that is the database descriptions. And what is database descriptions? Means packet exchange when OSPF adjacency being the form, the packet are used to describe the consent, right? Content of the LSDB. Means whatever the data means, once we agree, we are going to be adjacent. So there is one more question is going to be happen. What is difference between neighbor and adjacency? Neighbor versus, anyone know? What is difference between neighbor and adjacency?
Neighbor is any connected, and adjacent will be those who are also speaking on like OSPF.
Yeah. So neighbor is, it's not mandatory always going to be your adjacent router. Okay. The simple answer means, let's suppose you are, this is your house. Okay. And this is my house. We are same place. So we are the neighbor, right? But might be we do not have the good relations where we are not speaking to each other. So we are not going to be adjacent. Similar way, you are the router, I am the router, you enable the OSPF, and I also enable the OSPF. Both are the neighbor because we have the similar property, but we cannot form the adjacency unless and until I can start exchanging my database. Means unless or until we have the talk. Means you and me being the neighbors, we are not going to talk. That means we are not adjacent. So that's why when we exchange the hello informations, we have to be make sure the parameter is going to match. And what the OSP parameter is going to match based on the all like define the criteria. Means they're going to check each and every value, and if all those values going to match, then only your parameter is going to match. If anything is going to mismatch, you are not going to allow to uh, okay, you are not going to be allowed to like talk. So once we are agree, our parameter is going to match, they are ready to exchange a DVD packet, and this is known as the database descriptions. Packet are exchanged when the OSPF adjacency is the first being formed. So they are written adjacency, means they are the good neighbor. They have the all parameter matched. These packets are used to describe the contents of the LSDB. Means whatever the information database I have, I will share to you, and whatever database you have about the routing table, you share with me. So that's the LSDB. Then why LSR and LSU is there? So LSR is when router think I need some information about any route. Let's suppose it's something asking some information about any routes. Let's suppose you neighbor and me neighbor. I share my entire information, but still you have any confusion and you want to talk to me. Hey, Pankaj, can you just clarify about this particular point? So I will send my LSR link state request. Hey, can you just send me the information about that particular routes, which is not available in my routing table? So based on your request, I will send the update message if I have. So that is going to be LSR, link state update. And once you receive that, then it is going to be link state acknowledgement. So you can see here when the router think that part of the LSDB is stale means that is missing or not available. That is a cache. It may request a portion of the neighbor database. It's a partial in update. It's not the full LSDB update. LSR is going to be requested for the partial update, not the full update. And based on that, it is going to get LSU. LSU is going to be your just for the specific informations, which is going to be any specific link or network. Once it is done, it is going to be reply the link statement, link state acknowledgement. These packets are sent to respond the flooding level set, thus making the flooding reliable transport features. So it is going to just acknowledge, yes, everything good. I think we are clear till here, right? So we understand what is the message type in OSPF, and we understand how basically OSPF is going to be exchange the packets before forming the neighbor. Any doubt, guys, here till here?
So these messages will be shared between all, like all neighbors, or only with the DR and
No, all
the
neighbors. All neighbors.
all neighbors? Okay.
Yes, whenever you want to build the neighbors, it is going to be flood these messages.
Okay. Thank
Dinesh, any question you have, man?
Do you hear me, sir?
Sorry?
Do you hear me right now?
Means you have any questions or you're good?
That's what. Do you hear me, sir, properly?
Yeah, I can hear you properly.
The LSU packet you said, right, sir? LS, the first packet will be LSA, right, sir?
Mm-hmm.
So the second packet will be LSU,
Right.
and the third packet will be LSA, right, sir?
LSA, right.
Okay, so totally 3 packets.
Right.
Okay.
No, not 3 packets. Total, we have the 5 packets.
Hmm.
Hello, DBD, LSR, LSU, and the LSA.
Okay. Okay, sir. And one more that I just asked in OSPF, it will not support for unequal load balancing, right?
OSPF, yes, that's true. We can do that, unequal load balancing, but EIGRP support unequal load. EIGRP generally support
It
the
has variable,
balancing.
right, sir?
Yes.
Variance, I think so, right? Variance or variables.
Variance is EIGRP, not
Yes.
OSPF. Yeah,
Yeah,
right.
yeah, that's why easier to support for that unequal load balancing, right, sir?
Right. Variance command is there. We tested that.
Okay.
OSPF, we can do some sort of the load balancing, but
Manually we have to do that for,
because of
right?
the cost, right? It will not
Okay.
automatically do that.
Okay. So the further classes will be for the LSA type, sir. That is more important to me for that.
Sorry, last sentence.
I mean the further class, right? For LSA types, LSA1, LSA2, that is more important to me.
Yeah, definitely. We'll do that all. We are doing the theoretical today, and we'll do
Okay.
everything deep dive in very detail. Okay.
For sure.
LSA, we have to
Thank you, sir.
understand what is LSA1, LSA2, LSA3, LSA4. Everything we have to like detailed discussion, and we have to do in the lab how LSA is going to look like, how DR
So
selection.
can I have these notes too?
Can I have?
These notes, sir?
Yeah, you can get this book. Already might be it's available in your portal. You just check it.
Okay. Okay, sir. I'll check it.
If not,
Thank
just
you.
ask support team. They will help
Yeah,
you.
okay. Thank you, sir.
Yep. So now we have to understand whenever you want to make the any neighborship between any routers. So what is going to be happen? Let's suppose this is the R1 and this is the R2. So before you forming the neighborship, the very first thing, the hello packet is going to be exchanged. Very first thing, hello is going to be exchanged. So what is the neighbor state? Means before it is going to be full neighbor. Means I mentioned that adjacents means they are going to be full neighbor. So initially when you enabling the OSPF, they are going to be down state. Means you not configure anything or configure one side OSPF. Initially it will down state. Both are going to be down. So your link will be come up when you just enable the OSPF, configuring the IP and all. So it will try to go in the attempt state. So down is something. The initial state neighboring OSPF relationship. This indicate that router does not receive any OSPF hello packet. Means this side you configure the OSPF, but this side you not even enable this link. So it will not going to do any kind of this work for you. Simply it is going to be down state. But the moment you enable the OSPF, they will initiate to attempt. Means it is going to be basically in init state. Attempt is basically is going to use for the NBMA network, which is not relevant as of now. So initially it is going to be init state directly down to init state. Means because we are using nowadays point-to-point network, we are going to use the broadcast network, point to multi-point network, not NBMA network. So this is how it is going to happen: down attempt and in this state. After that, what happened? Once this down attempt init is going to be there, it will start talking to each other. Means state where the hello packet is going to be exchanged from one router, and it will also send hello packet to another router. So the parameter is going to be match. The poll parameter is going to match whether you are having the all informations, whether you're not having the all informations. And based on that, they will further agree to go in the next state, that is my 2A state. Because a hello parameter must be matched. If it is not going to match, it will never go in the next step. In this state, what happen? They will select which is going to my DR and which is going to my BDR. And this DR BDR elections, we have to do the detailed discussion how DR BDR is going to be elected. I will explain after that. But for timing, understand a state where bidirectional communication has been established. If DR and BDR is needed, it is going to be elected. This DR BDR election only going to happen if I have the broadcast network or might be NBMA network. If my point-to-point network, this DR BDR is not going to be elected. Very important. Okay. So DR BDR is going to be elected if it is required. If DR or BDR is needed, it will elected. Who is going to elect DR and BDR? The OSPF is going to elect in case of the my broadcast network is going to be there or NBMA network is going to be there. Clear? Once DR BDR election is going to be happen, what next? The next one is going to be my start state. In start state, what happened? Entire LSDB is going to be exchange. Means the first stage, the form and the residency router identify which router will be the master or slave. So master slaves selection is going to happen based on the priority, whatever the priority you have. So one router is going to be master and there is router ID. So highest router is going to be master and one is going to be your slave. And based on that, they will just exchange their database. So router identify which router will be the master or slave based on the router ID. If there's no router ID, the default selection is going to happen based on the your what I can say interface IP address. Let me show you. Why not able to copy? OSPF state masters slave selection process. So you'll see here. See, OSPF master selection extract has been highest router ID. So whatever the highest router ID we have, that is going to be master. If the router ID is not configured, then interface IP configured is going to be master, right? So the same thing they are talking here. So in case someone is going to ask who is going to be master, who is going to be slave in start state based on the router ID. Yes, Dinesh?
The second one is loopback IP, right, sir? The second election
Highest router
criteria is
ID.
loopback IP.
If loopback is configured, then it is going to come in picture. By
Oh,
default, loopback configured, it will be giving a router ID. If you're not configured
yeah.
manually.
If it
If there is
is
loopback, then
highest
it is
interface
going to be.
IP. Yeah,
If
sir.
there's
I have a doubt on that. Well, for the highest interface, while I'm doing the practical or that session, I will ask the question. Okay.
okay. Now the next state is going to be your state during which router will exchange the link state DVD packet. Means the exchange means router is going to be exchange entire your DVD packet, database description packet, and then it will go to the loading. Means anything they needed extra, then they will send the LSR packet. If not, they will go in the full state. So this is how it is going to be 7 state. 1, 2, 3, 4, 5, 6, 7. You just exit this one. So 1, 2, 3, 4, 5, 6, 7 state. of the neighbor OSPF state. Means whenever you want to build the OSPF neighborship, they will go init. Init, they will exchange the hello packet. Two-way, they select the DR BDR. I will explain how DR BDR is going to be selected and what is the DR BDR. Xstart, they select the master slave who is going to send the DVD packet first. Okay, that selection is going to happen. Then your master will share the entire DVD packet. Once it is complete, the DVD sharing, slave will going to be share. Then they will go loading. Loading means if still someone needing any additional informations, that is going to be shared by the again your packets by the routers, and then they'll go in the full state where my full neighborship is going to be exchanged. Any doubt in this particular slide?
Sir, can you come again with that exchange set, sir? DBD packets.
Exchange. Okay, so you select the master and slaves, right?
Hmm.
So once master slaves is going to be selected, master will send entire database to the slave routers.
Hmm.
So means somebody is going to send first, na? We are the
Hmm.
neighbor. So who is going to send my information first? There should be some rule, right? It's not like I'm also sending, you also sending. So it is going to be make some issue. So I will send first. If I will be master, you will have to be listen. If you are the master, I have to listen, you have to send. Then in this exchange state, they will do the same thing.
So the master will give the update to the every neighboring routers for that, right? Sir?
Right.
Okay. Loading speed.
Okay. So now we have to understand DR and BDR. So in every network, understand this very important. DR BDR selections. It's very important, guys. In every network, means if this is your one network, in the between you are going to find one DR and one BDR. If this is the one network, you are going to find one DR, one BDR. This is the one network, one DR, one BDR. This is the one network, one DR, one BDR. DR BDR elections. It is just going to happen in every broadcast network and non-broadcast network. So you see it, OSPF DR designated router, backup designated router, elected the multi network, and I will explain. Hold on, you're going to get the point to point doesn't support the DR BDR. Okay, that's the very important. And only see here. So in this also they are talking about the DR BDR election process, and see point to point multi-access network, because there's no DR BDR in a point to point network, right? So only DR BDR is going to be happen in the your broadcast network or multi-access network. So if you have any kind of the serial links, there is no DR BDR is going to be connected. So simple meaning of the DR BDR, any subnet you have, one subnet is one broadcast domain. They have the DR BDR. Per link, they have the DR BDR. But this is, think about, these all are the different routers, but they are having the same subnet. Then in this topology, we will find one DR, one BDR. And how this selection is going to be happen? There is three routers, okay? They are in the same network. See, all having the same series of IP address. They are connected to the switch. So they are the same broadcast domain. But this is the one subnet, one broadcast. This is another subnet, one broadcast. This is the one subnet, another broadcast. This is unbroadcast. So they are having the multiple DR BDR. For this network, one DR, one BDR. This network, one DR, one BDR. This network, one DR, one BDR. It's also DR and BDR. Clear? This one is clear? What I'm talking? If they are the Ethernet gig fast Ethernet, then DR/BDR is going to happen. If you're configuring these links as a point-to-point network, there is no DR/BDR is going to be selected. I'll show in the even the topology as well. But for timing, understand why this topology having the only one DR/BDR and why this having the multiple DR/BDR. Jason, Dennis, is it clear?
Yes, this one is a broadcast. And what was the multi-access? Multi-access is like for multicasting.
Multi-access is like frame relay network we have. Then again, we have the DR/BDR required.
Okay.
See,
Will we also do a lab of multi-access, or will we do
no,
only
we're not do it.
broadcast?
We're not there. BMA. See, non-broadcast multi-access network designated validated router are elected similar to the broadcast model, right? So based on the priority and all. So now if we have the NBMA network, very much clear. Let me write here. We have the broadcast or NBMA network. NBMA network. We require the DR and BDR. Clear? If we have the point-to-point network, then no DR, BDR required. I hope it is clear. Now, let's suppose this is my one of the broadcast network. Which one is going to my DR and which one is going to my BDR? Let's suppose they not have any kind of router ID configure. Any guess? Which router is going to be DR and BDR? By default, when you configure the OSPF, let's suppose you enable the OSPF in all router. Default priority is going to be 1 for the all router. If I make the priority 2 here, and this is going to be 1, and this is going to be 0. So this is going to my DR, this is going to my BDR, and this is going to my DR others. Okay. Or I can make priority 10, 5, 1. So this is going to be DR, BDR, and DR others. So any highest priority, if you're configuring your network, any highest priority is going to be there. That is going to be your DR. And second highest is going to be your BDR. And if it is not going to be any priority, means priority is 0 or any lower priority, that is going to be your DR others. Clear? Is it clear?
Yes,
So
higher priority will become
defaultly everything will be default priority, right, sir?
Yes. If default priority is going to be same for,
Highest interface IP.
so which one is going to be become? So if we have the router ID,
It will be a DR.
higher IP.
highest router ID, right? Whatever the highest router ID. Let's suppose you configure
So you
One
just
dot
eleven
configuring the router ID for 3 routers.
11.11.1. Here's the 2.2.2. Here the 3.3. This is going to be high. This is going to be 3. So this is going to be BDR. Okay. Because highest is 11. Or you just configure the router ID 1.1.1.1. Here is 2.2.2.2, 3.3. Then which is going to be DR in this case? Which will be DR?
3.3.
Three-
Highest
Going to
router.
be DR. This is going to be BDR. If
Sir,
there is no
for an
priority,
example,
yeah.
sir, for an example, I'm in among 3 routers. I'm not configuring router ID for one router. It will not communicate to the OSPF, right? It will not.
No, it will communicate. It will communicate. If you not configure.
It will you choose that interface IP as router ID, right, sir?
Right, right.
Okay.
Okay. Now, if there is no router ID configure, then who is going to become DR BDR? Highest
Interface IP.
Yes.
interface IP. So which is going to be DR BDR in this case? There is no
1.3.
huh?
Or 3.
1.3.
This is going to be DR. This is going to be BDR. Okay. And this is going to be DR others. So this is how it is going to select the interface. any router you purposefully, by default, I said priority is going to be 0. Okay. Sorry, priority is going to be 1 by default. But let's suppose I purposefully configure the priority 0 for this router. Then who is going to become my DR and who is going to become BDR?
R2 DR and R1 BDR.
Yes. Why? R2 is going to become a DR and this is going to become a BDR. But
Highest interface.
this is the highest interface. You can see.
But priority will change, right, sir? That is the priority.
So even now, if I put this one as 0 also, then what is going to happen?
Mm,
The first
then
one will be the DR, no DR, no BDR.
So any router which priority is 0, they will never participate in the DR-BDR elections.
okay.
Any router which priority you configuring 0, they will never participate in DR-BDR elections. Clear?
Yep.
All right. So this is how it is going to happen. So probably you guys have the good theoretical knowledge, DR-BDR, right? And I hope you will able to make it when we do the lab. Let me see what else I can cover for today. I believe we are good for today. Let's just start the lab part from the next class and we'll cover the all theoretical concept one by one. Will it fine?
Yeah, sir.
The classes will be regular from next week.
Yes, it's regular. No holiday now. It's going to be
So it's Monday to Friday, right, sir?
It's Monday to Friday, and I'll finish all topic one by one. Don't worry, okay?
Okay, okay,
Lot of
okay.
holiday we have done. Now no holiday because all holiday has been finished. If there is emergency, I'll let you know. But probably it is going to be very much regular.
Okay, and like when are we going to finish this? Just for an overview, how
Oh,
much time have you
it will
planned?
take this month at least. We'll have to be used on regular, okay? 1.5 hour session. So we'll see after this
Okay.
month how much we're going to go because it's going to be 5 day session and one and a
Yeah.
half hour regular. So it is going to be, like very extensive session. So probably we'll cover a lot of things by this month.
Next month Tuesday I have on-site.
No problem.
So if you can do a short session, so on the next day I will be back. It
No
is
problem.
Tuesday
We'll,
4.
we'll, we'll try. We'll try. Okay.
Okay. Thanks a lot.
Thank you so much. Bye bye. Take care, guys. Bye bye.
Thank you,
Take
sir.
care.
Thank you.
Bye.
Bye.
Good evening. Bye.